Aviation engine building is a large industry, and it has its own stars, powerful and outwardly very impressive. But among them there is another group of engines, not so large and powerful, and outwardly often not even visible. But these fiery hearts are no less important, because they are the ones that lift mass aviation into the sky, small planes and helicopters. Hello aviators, Sky here, and today one of the youngest fiery hearts awaits us. I present to you the turboshaft VK-650V. Light helicopters are everywhere. Such machines are not impressive in size and performance, but they are multifunctional and available for mass use. In the USSR, the main light helicopter was the Mi-2, a well-deserved and beloved veteran that dominated the skies for decades. But by the beginning of the 21st century, it was hopelessly outdated and in need of replacement. Replacement has arrived. Light helicopters of a new generation, such as Ansat and Ka-226, took to the skies. These machines had quite a good performance and began to be produced more or less actively. But then came a problem of the Mi-2's success. Soviet and Russian aviators, clearly keen on cool and more powerful machines, practically did not work on light helicopters for decades. The little Mil was doing all the work. But the result of this was that when the new light helicopters appeared, it turned out that many systems for them were simply not made in Russia. And the main thing here, of course, was the engines, which had to be improved. The fiery heart of Ansat was the turboshaft Pratt & Whitney PW207K, and the Ka-226 accordingly received the Turbomeca Arias 2G1. At first, this was not critical. International cooperation helped, standard practice in aviation. But by the mid-2010s, this nuance nevertheless became a problem. Firstly, light helicopters and also engines for them are a big market, and engine builders could no longer ignore it. Secondly, a political barrier arose. The refusal of foreign suppliers to work with Russian manufacturers led in fact to Ansats and Klimovs losing their engines, without which they are just very expensive carts. The answer to these two questions is obvious. You need to make your own engine, from scratch, completely new. The first work on it began in 2018 at the Klimov company, one of Russia's main engine production enterprises, the current division of the United Engine Corporation. By 2019, the project was officially initiated. According to tradition, the letters of the index are made up of the initials of one of the fathers of the entire enterprise, Vladimir Klimov, that is, VK. As a result of research, it was calculated that the optimal takeoff thrust should reach 650 horsepower. And since we are talking about a helicopter turboshaft engine, another V was added to it, the first letter of the word vertolyot, Russian for helicopter. This is how the VK-650V began its journey, and now we have the opportunity to get to know it better. The Klimov company is located in St. Petersburg, where the weather greeted me with an obvious question. What did you expect from a northern city at the beginning of October? The company itself has changed significantly over these few years. All the facilities, production, warehouses, design bureau and testing base are now in one place. Many new buildings filled with many interesting things, most of which I won't show you as it's not allowed. But I'll show you the engine itself. So, standing before us is the VK-650V. To understand why it is exactly like this, I will point out that in 2019, the Klimov team was given a task of making an engine that is economical, cheap and easy to operate, in all respects at the level of its peers around the world. And it needs to be done as quickly as possible. Now to the layout. Air enters the engine through the annular air intake. Yes, not from the front, but from the sides. Next, it goes into a centrifugal compressor, whose task is to compress the gas and drive it into a counterflow combustion chamber, in which it is mixed with fuel and ignited. Hot gas under enormous pressure gets thrown at the compressor turbine, a classic axial one. The turbine, being on the same shaft with the compressor, rotates it, making everything work. Having passed the compressor turbine, the gas passes through another stage, the free turbine. The free turbine is located on its own shaft, which transmits its rotation outside the engine. It is this that ultimately turns the helicopter's rotors. Behind the free turbine is a nozzle from which gas is thrown out. It is still hot and compressed, but after passing through 2 stages of turbines, it loses most of its energy, so there is practically no jet thrust here. In front of the air intake, in a jumble of mechanisms, pipes and cables, a gearbox, a starter, and the fuel system control mechanism are hidden. The layout ended up being quite simple. Single-stage centrifugal compressor, counterflow combustion chamber, single-stage compressor turbine, single-stage free turbine. The bare minimum. In terms of materials and components, everything is also quite simple. A balance of aluminum, steel and titanium alloys in parts, plus modern heat-resistant alloys in the hot part. Tight and compact. The VK-650 is similar in size to the analogs used on the Ansat and Ka-226, so the helicopters don't need to be significantly modified. The engine weight is also small, at around 115 kilograms, 250 pounds. Power output, meanwhile, ranges from 400 horsepower in cruising mode to 650 horsepower in takeoff and 750 horsepower in emergency mode, which can be maintained for 2.5 minutes. Fuel consumption, about 245 grams per horsepower per hour in takeoff mode. Not a green revolution, but not bad. That is, the engine is quite simple in design, which became one of the bases for the speed of its creation. But this was not enough, and the engineers also resorted to other measures. The first is the large-scale use of electronics. Digital design, 3D, and computer modeling in our time are almost a mandatory set for the creation of any technology. They not only seriously optimize processes, but also make it possible to avoid a lot of work on the ground, which is much more expensive and requires a lot of time, which, I repeat, is scarce. The second solution is additive technologies, 3D printing. In our case, the main bonus of 3D printing is speed. Each new part does not require modification of any large production facilities. Designers send computer models to the manufacturer, partly Klimov itself, and partly the Rostec Additive Technologies Center, which makes the parts. In the case of creating prototypes, this is an ideal solution. A significant portion of the parts in them are printed, and very quickly. After the transfer of design documents to the manufacturer, the parts were received in about 6 months. In the past, this matter could take years. However, we shouldn't expect a particularly large share of additives in the series. This work requires an additional regulatory framework and certification, and with mass production, classical manufacturing methods are often cheaper, so decisions need to be made on each part individually. Thanks to these decisions, the work was carried out very quickly. While the project was initiated in 2019, by the end of 2020, the demonstrator had already been assembled. By the end of 2023, the engine is almost ready, and waiting for certification tests, followed by the start of deliveries. You can rarely see such speed of work. In modern aviation, no one is surprised by projects with a completion time of 10 years. Moving forward. Above all these turbines, compressors and nozzles rises one of the most important elements of the engine. This little black box is the Full Authority Digital Engine Control System, or FEDEC. In this case, VK-5V, a completely new unit created by the Klimov team specifically for the VK-650V. This small computer, on the one hand, makes it easier to pilot a helicopter, and on the other hand, it optimizes the operation of the engine, constantly monitoring a large number of parameters and, among other things, preventing it from entering harmful and dangerous operating modes. The functionality is classic. Nowadays, it is difficult to imagine a more or less complex aircraft engine without it. Another essential advantage of the engine is the modular design, which means that it is much easier to maintain and repair than a monolithic block. The combination of simplicity, quality of components, modularity, and advanced automation significantly improves one of the main parameters, the simplicity and cost of its maintenance. The VK-650V is created in accordance with the requirements of the Russian so-called Second Resource Management Strategy, which builds a much more convenient maintenance scheme when the total required resource of the engine is replaced by the resource of a number of its main components. According to this indicator, the VK-650V is oriented at 3,000 takeoff flight landing cycles in the hot part and 6,000 cycles in the cold part. In flight hours, these are roughly 4,500 and 9,000 respectively. Thanks to this, to a large extent, we can assume that the eternal problem of the resource and maintenance of old Soviet and Russian engines is a thing of the past, and the VK-650V is at a decent level. This engine design, both in layout and in systems, is considered optimal for engines of this power class. All peers, give or take, are the same. One can complain, of course, that the decisions are too conservative. Is the VK-650V close to analogs? But we are comparing a brand new engine with members of families that are decades old. Couldn't they come up with anything new during this time? Where are the composites, cooled blades, ceramic coatings, increased pressure and temperature indicators? The solutions used in the current engine are the golden mean between performance, cost, and creation time. In this category, the most important thing is balance, any deviation from which can lead to the engine being either ineffective or too complex and expensive. Again, their foreign counterparts are brainchildren of industry leaders. Their creators have all the resources and technologies, however they are in no hurry to introduce them, for the same reasons. But it's not completely without futurism. The VK-650V has another potentially interesting role as part of a hybrid power plant. The design is simple. The engine is connected to a generator in a power unit, which generates electricity that goes to the batteries and electric motors, which lift the machine into the air. At the moment, this technology is considered one of the most promising, because conventional engines have practically hit the ceiling in terms of fuel efficiency, ecology, and economics, and the more breakthrough solutions often come to us accompanied by exorbitant risks. Unlike the purely electric power plants, such a hybrid is still based on a gas turbine engine generator, and the batteries provide only about 20% of the power that is used in peak conditions, reducing the load on the engine, increasing its lifespan, and improving fuel efficiency. Improving significantly. The UEC took up the task, and Klimov became the lead executor. The research project was initiated in 2020. At the first stage, the concept was tested on an installation with 4 electric motors and a power unit with an output of about 150 kilowatts, the core of which was the VK-100 engine, a lightweight turboshaft which, in ordinary life, serves as an auxiliary power unit for MiGs and Sukhoi. By 2023, engine builders moved to the next stage, the creation of a more powerful 500 kilowatt power plant with 2 electric motors and a power unit based on the VK-650V. The work is being carried out quite actively. Most of the elements, the power unit and controls, are the responsibility of Klimov. The remaining components, such as electric motors and batteries, which are not entirely the company's specialty, are supplied by partners. Already in 2024, all research and testing work should be carried out, after which, in theory, the brightest stage should follow. All this must be lifted into the air to prove that the hybrid power plant is good, not only in presentations and at stands, but also in real flights. At the end of 2023, the VK-650V can be considered almost ready. Ansat and Ka-226 are being adapted to the new engine using mock-ups. After a slight modification, they will be equipped with full-fledged prototypes, and in 2024, it is planned to begin certification tests of both the updated helicopters and engines. According to current plans, the updated Ansats with VK-650V engines should begin to be delivered to customers in 2025. At Klimov itself, preparations for serial production are now underway, which in theory should reach a rate of 70 units annually within a few years. I'll note once again that there are a lot of helicopters in this class in the world, and the potential market for such engines is huge, so it will not be particularly surprising if in subsequent years the VK-650V or its modifications begin to take to the skies not only the Ansats and Klimovs, but also other machines. Well, let's wish them good luck. A lot has already been done, but much work still remains. We'll find out the end results in about 10 years. Thank you to the Klimov company for letting me in and showing me the motor. And you, lovers of everything flying, comment what you think about the prospects. And if you want to watch the videos early, see some exclusive behind the scenes content, or just support the channel, consider joining our Patreon community. Fast flights on aircraft with good engines, and soft landings to you.